Okay, Assalamualaikum. Hi everyone. Okay, today we are going to discuss 5.1, which is functions. For today, we are going to look at the learning outcomes for today is the first one is sketch the graph, which is we are going to use graphical approach or graphical method of a function, and the second one is state the domain of the range of the function. So for this part, I'm going to discuss constant function and linear function. Okay, for graphical approach or graphical method, first I would like to state what is the domain first. Okay, the horizontal axis, x-axis, representing the domain of the function x-axis, and the definition of domain is the set of the value of x in which fx is defined. Okay, while the vertical axis, which is y-axis, representing the range of the function. And then the definition for the range is a set of all the possible value of fx as x varies throughout the domain. Okay, we look at the functions for graphical method. We are going to use first constant function, a polynomial which consists of linear, quadratic, and cubic functions, rational functions, or sometimes we call it reciprocal function, set function, absolute values function, and last part is piecewise function. So piecewise function is a few function consists of few functions. All right. Okay, so we go to constant function first. Fx equal to -8. Sometimes we can write fx -8 to y -8. Okay, and then how to sketch this graph? Okay, look at the value of -8 here. So the graph is constant at -8 at y. So you put -8 at y-axis and put a constant line at y -8. And then after that, how to write the domain? So the domain, sometimes we put df, domain of f. And then how to write the domain? Okay, from here we can see that all x are mapped to y from -infinity to positive infinity. All x, domain we refer to x. Okay, so all x are mapped to y, which is -8. So the domain is -infinity or infinity, or sometimes we can write real number. And then for range we can write R, range of f. The range, okay, so the range we refer to y-axis. So for y-axis, we have the one value only, which is -8. So the range is y is -8 or -8 only. Okay, let's move to the next example. Fx equal to 2. So this one, you can write y equals to 2. So y, so we put 2 here, which is 2, and then put a constant line here, y2, and then from here you can write the domain which is all the x values mapped to y at 2. So we can write -infinity, infinity. How about the range? Range f is y equals to 2 or 2 only. fx equals to ln e to the power of -2. Okay, this equation we simplify first. So you'll get -2 ln e, because -2 we can put in front. So ln e is 1, so you get -2. So now your equation is y equals to -2, your constant function. Okay, now put -2 here and then draw constant line. Okay. And then for the domain, we can write instead of interval form, we can write into set notation, which is x, where x is the element of real number. So all x are used to this function. And then for the range, we can write y equals to -2. Okay, let's try this question. Okay, sketch the graph and state the domain and the range for the following functions. A, fx equal to -5/2, and B, fx equal to log 4 base 2. Okay, A, fx equals to -5/2, which is -2.5. We draw x and y axis. Okay, and then this is a constant function. So put -5/2 here, and then draw a constant line. So from this, we can write what is the domain. The domain is all x are defined. So -infinity, infinity, or real number. For range f, we can write -5/2, or we can write y equals to -5/2. For B, fx equals to log 4 base 2. So this one, we simplify first. So you'll get log 2 base 2 to the power of 2. So now 2, you can bring in front. So you'll get 2 times 1, which is 2. Alright, so actually this is a constant function y2. Okay, after that we draw x and y axis. This is x, this is y. So y2 is here, and then we put a constant line, and then from here we can read the domain and range. Okay, domain is, we start from -infinity to infinity, and range of f we will get only 2. Okay, now we go to the polynomials. Okay, first linear function. Okay, what's a linear function? A linear function is of the form of fx equal to ax plus b, where a and b are constant. So the graph of the linear function is a straight line. Alright, for the linear function, we have two types. First, when a is positive, okay, a is positive, which is the gradient. Gradient of the function is positive. So the coefficient of x here is a is positive. So the graph is increasing. Alright. For fx is ax plus b, where a is negative, so the graph is decreasing. And then for the domain and range, for the linear, both are real numbers. So the domain for linear function. All x are real numbers, or we can write negative infinity, infinity. And range of f is y is also is element of R, which is negative infinity, infinity. Okay, now fx equals to 1 over 2x plus 2 is a linear function. So this one is a linear function, x power 1, you can see here, x power 1. And the gradient is positive, so the shape of the graph is like this straight line and it's increasing. So how to sketch this graph? So actually to sketch this graph you need at least 2 points. So for my method I use x0 and I have to find what is the value of y. When y is 0, so I get a value of x. So you can test the value here. So when you get x0, when x0, you get y equals to 2. So you put 2 here. When y is 0, so you get 0 equals to 1 over 2x plus 2. So you get x adalah negative 4. So you get 2 points there. So from that, so you get negative 4, 0, 0 and 0, 2. So this is 0, 2. And then once you get these 2 points, you connect these 2 points, you get a straight line. Okay, then how to read the domain? The domain here is all the value x are used to map the y. So the domain is negative infinity, infinity. At the same time, y for the range also is negative infinity, infinity. Okay, look at the equation. Fx equals to negative 4x plus 1. From here, we see that x is power 1. This is a linear function, and the gradient is negative. The gradient is negative, and the shape of the graphs must be like this, descending. Okay, now how to find the points, at least 2 points. So we check here, when x0, when x is 0, you get y1. When y is 0, you get x is 1 over 4. So let's put the point. So let's say this is 0, 1. This is 0, 1, 0, 1, and then 1 over 4, 0 is smaller than 1. So 1 over 4, 0. And from this, you connect these 2 points, and the gradient is negative. Okay, so this is a straight line. And then from here, we can write what is a domain. So from here, the domain is negative infinity, infinity, or real number. And the range also is negative infinity, infinity, which is real number. Okay, let's move to another example. Fx equals to negative 3x plus half. Okay, this is a power 1 and the gradient is negative, so the shape should be like this. Okay, and then test the value. When x 0, you get y half, and then when y is 0, you get x 1 over 6. So from here, you join 2 points, so 0 half, let's say here, and then 0, 6 here. 160, sorry, so 1 over 6 here, and you join these 2 points, you get a linear equation. Okay, so from this we can write the domain negative infinity, infinity, or real number, and the range also is negative infinity, infinity, which is real number. Let's try this. Sketch the graph and state the domain and the range for the following functions. Okay, a fx equal to 2x plus 5. Alright. To x plus 5. This is a linear function. The gradient is positive, so the shape of the graph like this. So when x 0, when x 0, 0, you can see that y is 5. When y is 0, you get negative 5 over 2, right? Correct. Alright, after that, we draw both axes, x and y, and then we put the coordinates. Okay, 0, 5, 0, 5 is here, 0, 5 here, and then negative 5 over 2, 0. So let's say here, negative 5 over 2, 0. After that, you join these 2 points, straight line with a positive gradient. Okay, try one more time, because it's not like a straight line there. Okay, alright, so just okay, so we get these 2 points and join these 2 points, and then you can write what is the domain. Domain is negative infinity, infinity, and the range also negative infinity, infinity. Okay, for b, fx negative x plus 2, so this one, the gradient is negative, so the shape is like this. So try to test 2 values here. When x 0, you can see that y2, and when y 0, we can have x2, correct? Alright. After that, draw both axes, x and y, and then put the points here. We have 0, 2, 0, 2 here, and 2, 0 here. 2, 0, 2, 2, 0. After that, you connect these 2 points. Okay, you get a straight line with the gradient is negative, so the domain is negative infinity, infinity, and the range is also negative infinity, infinity. For question C and D, you try to solve it.